Hi everyone, we're going to identify and graph the polar equation r equals 1 plus 2 sine of theta. This is a Limacon. We have to identify it with an inner loop. I will show you the form for that momentarily. For now, let's test for symmetry, and that's for graphing purposes. It's going to make it easier to graph if we know if it's symmetric to the polar axis or to the y-axis. So let's test the polar axis first. That means we take our r and we substitute in our theta with negative theta. Basically, you're testing even odd functions on this one. So for the negative theta, sine is odd, so we're going to get 1 minus 2 sine of theta, because you can pull this negative out here. Since these two equations do not equal, that means this test fails, and our graph is not going to be symmetric with respect to the x-axis. Let's do the second test. It should work. So we're going to replace our theta with pi minus theta. So we're going to get r equals 1 plus 2 sine of pi minus theta. This has this form here for sum and difference formulas. So let's expand this. I'm going to move it down here so we have more room. This is going to be equal to 1 plus 2. Then we have sine of pi times cosine of theta minus cosine of pi times sine of theta. All right. Sine of pi is 0, so this knocks all this out. This is 0. Cosine of pi is negative 1. Two negatives make a positive, so basically we're just going to get r equals 1 plus 2 sine of theta. Since these two are equivalent, that means this test passes, and our graph is going to be symmetric with respect to the line theta equals pi divided by 2. Our third test is the pole test, the origin test. You substitute your r with negative r, and clearly these do not equal. This only works if your r is squared. Now what we have, so this fails. What we have is a Limacon with an inner loop. It's the inner loop because it has this form where a equals 1 and b equals 2, and b is greater than a. Since b is greater than a, it has an inner loop. If it was reversed, if these two were reversed with 2 plus sine of theta, then it would be without an inner loop. So that gives you an idea that it's going to have this some kind of inner loop here, like that. So let's graph it. We know that our graph is symmetric to the line theta equals pi divided by 2. So what we want to do is assign values to theta from negative pi divided by 2 to pi divided by 2. So let's do that. We have negative pi divided by 2, negative pi divided by 3, negative pi divided by 6, 0, pi divided by 6, pi divided by 3, and then pi divided by 2. And we're trying to find our r value by substituting that in. And our r is 1 plus 2 sine of theta. So let's evaluate all this. At negative pi divided by 2, my r is going to be negative 1. At negative pi divided by 3, we have 1 minus square root of 3, which is approximately negative 0.7. At negative pi divided by 6, we're at 0. At 0, at 1, 2. At pi divided by 3, we're at 1 plus square root of 3. That's approximately 2.7. And at pi divided by 2, we're at 3. So let's plot these points. At negative, pi divided by 2, this is this one, we're at negative 1. So that's going to occur here. Remember, this would be 1, but since it's negative 1, you go this way. That's your r. So we're going that way. All right. At negative pi divided by 3, which is this one, we're at negative almost 1. So it's a little closer in here. At negative pi divided by 6, we're at 0. So we're starting here. Let's graph some of this and going this way. At 0, we're at 1. So we're back out to here. Let's see. We had negative 1, and at 0, we're at 1. So it swings around this way. At pi divided by 6, we're at 2. So go out 2. And then at pi divided by 3, we're at almost 3. And at pi divided by 2, we're at 3. So now what you have to do is use your symmetry to come back around. So if you come back around here and work backwards, at 2 pi divided by 3, we're going to be at 2.7. It's close to 3. Coming back around. Then at, the pi divided by 6, or 5 pi divided by 6, would be at 2. Then at 0 would be at 1, which is here. So we're coming back around. And then we're going to be at negative 0. So this is going to swing around, come back around like this, and come back up and loop up like this. So that's how it goes. You just have to substitute in the values. We started at negative 1 here, and then it went around this way, then it came back around and looped around this way. And that's our graph. Thank you. Have a nice day. Bye-bye.